So today we're going to look at the computer application in stormwater management model. At the same time, we'll try to marry it with first principle. So first is you go to this website, epa.gov, you search for stormwater management model called EPA Swim, EPA Swim, then you download it. We download it, you run the setup, and then at the end of the day, this is the interface of the software. This is what the software looks like. So it looks like APANET also. So here you have the menu. Here you have the standard toolbar. This area, you have your map area. This is called study map area. This is where you do the mapping, the study. And this area is called the toolbars. Mind you, I can lift up this toolbar and drag it. But for now, okay, this is where they put it now, just like AutoCAD. Some of you will see your own. The previous versions, the toolbars are here. So for the toolbars, the first one is called the select object. Use it to select objects. The second one is called vertex. We've done that one before. The other one is region, to select a region. The other one is to pan your view. The other one is zoom in. The next one is zoom out. The other one is zoom extent. You want to zoom everything. And this one is to measure a distance or area. This one is the rain gauge. If you want to put in rain gauge. This one is a subcatchment. If you want to draw a subcatchment. This one is a junction. This one is an outfall. I explain what outfall are. Where your pipe network interfaces with the open stream. Where the water discharges into an open body. It's called an outfall. This one is a divider. This one is a reservoir. This one is a conduit. We'll call it conduit, or the same thing as pipe or drain, right? But the technical word in EPA Swim is called conduit. That's the conduit. The next one is the pump. We hardly use a pump in storm and sewer design, except at the treatment plant, so that you can lift the water from the low level to the high level. And this is called the orifice link. This one is called the wear link. This is called the outlet link. And this is called the map label for putting labels. So this is how it works. The first thing you do is you go to title, you put in, you go to your options, you set them, you take care of the climatology, you talk about the hydrology, you now talk about the hydraulics. Under the hydraulics, you should be able to talk about two broad terms, the nodes and the links. The street, the inlet, the transat, the control. After that, you can start to do quality analysis, then curves, then the next one you do time series, time pattern, and so on and so forth. So now, let me bring an example of what we're going to do the same exercise that we did in the rational method. Is what we're going to do. So this is AutoCAD. The software does not understand AutoCAD. JPEG. This is PDF. What the software understands is JPEG, bitmap, or meta files. Please take notes. Meta files or bitmap of JPEG, picture format. But there's a way I can convert this. So I want to use this as my layer. So I want to design this network, this same network for storm. I want to design this for storm. So what I'll do, number one, I can go to it, I'll copy it and take it into an image, I'll first take it into a program that can convert it to JPEG. So if I double click on it, I can say copy image. So after copying it, you go to your computer system. There's a program called Paint. It's in every computer, just like CorelDRAW. Want to raise your picture, want to do anything on picture, want to work on picture as an engineer, you use Paint. When I go to Paint, I'll go and click, here is paste. So I'll click paste. It will paste it here. So what I'll do here is that I can crop it. So I'll go to crop. I'll come here. I'll draw a rectangle. Press enter again or press same crop. It will crop it this way. I can come here now. I'll save it as JPEG or bitmap. So I will save it where I can find it. So let me just save it on my desktop for the purpose of this training. And I'll call it what? I'll call it the 6 layout or map. Take note of where I'm saving it. Actually, I'm supposed to save inside the folder, but let me just save it. The desktop is also a folder. So I've saved it. So when I go to my swim, I will now import it. I'll go to I'll go to view, go to backdrop. The same thing we did in APANET. View, backdrop. I'll say load. You say image, backdrop image file. So where did I save it? I'll go to desktop. I'll look for the 3. Is it? If I want it to be georeferenced based on world coordinate system, I'll click here. I don't think I want that. That's imported. Is this understood? So I have introduced catchment here. The next thing I do is that there are about 1, 2, 3, 4, 5, 6, 7, 8 catchments in one single catchment. I can identify 8 subcatchments. So I'm going to digitize them. So what do I do next? I will start with subcatchment here. Add the subcatchment. So I'm going to click on add the subcatchment and add all the catchments, subcatchment. So I'll click on subcatchment. I'll come and draw it. I'll trace the outline. When I get to the end, I'll just right click. I've drawn that subcatchment. It looks simple, but this subcatchment can be Ikoyi, VI, Wuse, Kado. What have you? So I will keep on doing like that. I'll click on another subcatchment and I'll trace the boundaries of this subcatchment C. So please, can I give you 5 minutes? I'll pause the recording. Can you import? Get to this point and ask me a question. So I just want everybody to import this. Very important that you know how to import it. Can someone try his hand on it? Wrong. I didn't close it. So what I'll do, I'll go and pick select 2. I'll click on this wrong one, click on the center, press delete. You have to confirm or delete it. Please, I know it can be daunting, but just try to play around with it. So these are the subcatchments, and they are coming out very fine. The last one. I didn't get it. So I'll go back, click select tool, click on it. So you could see I've done the starting the catchment, but these points are too tiny. So I'll go to view and I'll try to increase them now. So once I click this select tool, I'm out of it. So when I'm here, I'll go to tools. I'll go to map display options. So here it says nodes. I'll increase it to say 5 or 6. Link, I'll increase it to say 2. So So we'll talk about. So this one, if I want to see it to display on the ID, I'll put it, but it's not necessary. Any questions so far? So this is what I have done. The next thing I need to do is to now either I remove the backdrop, but let me put the nodes and the links. So here, I'll put the junction here. Exactly the same place it is. But for me to see it very well, let me just put on top. I'll put another junction here. Put one here. So I'll place them. My job is to digitize this network to reflect what's existing, because I will soon remove this one now. So this last one, I'll not put a node, but I'll go and carry an add fall. That's the last point. I'll put it there. This thing is looking small. Let me see if I can increase it. The nodes, 6. Next, I've drawn the catchment. Next, I'll go and draw the pipes. I'll connect them with the pipes. So I'll draw it at the center. Click on this one. So you can see I've drawn the catchment A, catchment B, catchment C, catchment D. The next thing I need to do is, let me go to that map display option, and I'll ask him that the node should be high. Then annotation. I want some annotation to show. I'm about removing the backdrop, so I can easily go to view, backdrop, unload. That becomes my network that I want to model. So if I want, I'll click on this tool. Double click here and call it A. B. This one was C. So once again, for those who are joining us, we are on computer application. Go to, let me pause this. So before we go further, let's just review the catchment method again. So this is the layout. This is the catchment A, catchment C, catchment B, catchment C. And let's assume if water is stormwater or sewer, the wastewater flow is coming like this. It comes here, this one joins it. It comes here, this one joins it. It comes here, this one joins it, and so on and so forth. So this is catchment A. So all the houses connected to the catchment will come into this place. Then all the houses in this catchment B will come into this place, joined by the one from here. All the catchment from catchment C will come to this place. No, catchment C will come to this place. Catchment D will come to this place, joined by C and joined by B. So as it's going downstream, it's getting high and high. And the way to proceed is that you draw a table like this. So you could see that this table and this other table are the same thing. Yes, they are the same thing. Here is that we multiply the area of catchment by the flow. And how did we get that flow? Here is how we got the flow. The wastewater, the dry wastewater flow. Multiplying the water demand per day, wastewater discharge times the number of persons contributing to it, which is the population demand, multiplied by the safety factor, add the filtration water, we'll get our values in liter per seconds per hectare. So this liter per seconds per hectare means when I now come to the first catchment, I'll simply multiply that 0.401, which is the amount of wastewater coming to the catchment, by the corresponding area. That will automatically give me the wastewater flow. However, as we are going down, the catchment is increasing. I'll do the same for all of them. And I'll stop at column 5. So column 1, 2, 3, 4, 5, that's where we'll stop. How did we get column 6, which is accumulation? We got column 6 by reminding ourselves that when this wastewater flow is coming this way, when it comes to B, it will become A plus B. When it comes to D, it becomes B plus C. Why? Knowing that A has been completed into B. When it comes to here, it will become D plus E. So this is how it will be going. And as it's going downstream, the thing will be increasing in volume. That is why your wastewater pipe will keep increasing. So doing it rationally or in a table form, what it means is that A is 6.26, and this is this. When it comes to B, it becomes the value for B plus the value for A becomes the accumulated flow for B. When it comes to C, C remains C. C remains C. There's no upstream. E will also remain E. G will also remain G. Take note of that. So we go to D. D, the value for D is 1.4757. If you look at catchment D is very small. So you don't expect it to produce too much wastewater. So it's proportional if you look at it very well. This one was producing 6. This one was producing 2.19. This one was producing 6. So you could see that the wastewater contribution is a function of the area of that catchment. And it makes sense. The bigger the area, the bigger the number of houses. The bigger the number of houses, the bigger the residents of that place. And the bigger the contribution of wastewater or even storm. So D becomes the value of C plus the value of B. I would have said the value of B and the value of A, but no, B has already. So if you want to know the value here, it will be this plus this plus this plus this, give you this. But when it comes to E, E is independent. It does not have upstream. So E remains E. F becomes E plus D plus itself, give you F. So you can see, when you go to G, G remains G because there's no upstream. While H will now be the total of all of them because H is at the end just before the outfall. Any question? I think this one is very self-explanatory. So while we went to do the catchment, oh, sorry, before we go there. So after getting this in the table, we now decide to measure the catchment characteristics. How do we get our peak-off runoff? So we analyze all the surfaces and we got an average runoff of 0.37. Yeah, that was the average runoff. Using the mean weighted average, we got 0.37. If you're looking at the individual runoffs, you might be deceptive. The average is what we use. So design storm. So when it comes to design storm, we use 10 minutes rain, and we are designed for a rural area. These values will help us to select the equivalent safety factor or time period to use. The population equivalent to use, the storm weather flow is 100 capita per hectare. The water consumption is 130. The peak factor is 2. Water is 0.1. Roughness of the pipe, which is a concrete pipe, is 1.5. So when you put all these things together, this is the wastewater flow per seconds per hectare. While this is the formula we use to determine the runoff flow. But before we do that, we need to ask ourselves, what are we designing for? Is it against storm, which is normal thing? Is it against discharge? Is it against flooding? The higher the risk, the higher the value. So for stormwater flow, rainfall intensity times the precipitation, you get it. Then we went to our IDF, and after considering many factors, we got 126.3 at 10 minutes return period of 1 year. We now follow this step-by-step approach. And what was the result of what we got? Here is it. We used 10 minutes rain frequency. We decided to use 5 years. This for surcharge or normal drain in high risk area. Then peak runoff is 0.37. So here we now calculated So for catchment A, the area is 15.63. We multiply by the peak runoff coefficient to get the reduced area. That reduced area was 5.8. So 5.8 you multiply by the rainfall intensity. Rainfall intensity times area. Okay. So if you now want to get the equivalent flow for that catchment A, it will be the reduced area multiplied by the rainfall intensity. So that will give you this. So once you've gotten the discharge, then you know the slope, you know the pipe roughness, you go to your chart and you reduce your pipe size immediately. So against 5 per mil from table, we're able to get 700 mm pipe for catchment A, which is the last catchment. For catchment B, it is the area times the runoff coefficient, total area, to give us the effective area or the contributing area. Multiplying by contributing area by 126, you get 267. However, catchment B has an upstream, and that upstream is catchment A. So we add the value of catchment B, the value to catchment A, to give us this. So catchment C, area of catchment is C, 14. However, we're not interested in the total area, we're interested in the reduced area, which is the area contributing to runoff. And that will multiply it by a peak runoff coefficient to give us this 5.22. Multiply by 5.22 by the average precipitation in that area to give you 658. And with 658, it means that catchment C will just be like catchment B, will just be like catchment A, which is this. Okay. So at the end of the day, we got 800 mm pipe. My question is, do you still remember how to read it off on nomogram? The answer is yes, because that was something we did in EPANET, water distribution. So this is this. Catchment E, to design it. So this is how you go on and on and on and on and on for all of them. For Siwa, almost the same thing. For Siwa, you follow the same step. What changes this time around is that we are talking about circular pipe. We're limiting ourselves to circular pipe, number one. And we can determine the water demand per capita per day. So once I get the water demand per capita per day, I choose a safety factor of 2, parasite total of 0.1. Then I'll do the calculation. So this is it. Size of a combined sewer system. So we'll continue from here and so on and so forth. So I think this is quite self-explanatory. I don't think there's any question or there's something somebody doesn't understand. So if that is done, we'll have to go back to the computer application. So once I've done this way, I will now start to impute those values of this. But to make our life easy, to make this work easy, Let's go and do one exercise. So let me share one exercise. I think that will help. Just stay with me, I'm coming. Yeah, tutorials. Okay. So where do I put it now? Please go to the chat box and download 2 tutorials. So one used to practice. The step-by-step tutorial that will give us more insights. So this is it. So please, let's all download it. It's in the chat box now. So we're going to construct this simple model so that everyone will be on the same page. So how do you proceed? You draw this model. Okay, now this one is scattered model. The other one we have is A, B, C, D. They're all, together in one piece, in one parcel. But this one is in different parcels. So the same thing is what you do. So what are the first thing you do? You draw the catchment like this, right? So let me come here and say new one. So the first thing I do is I come here, I'll draw something that looks like Ikoyi. If I want to move it, I'll click on select to. I'll move it up. I'll click on the center of the subcatchment, press it down. I'll move it up. So this is what I'm trying to draw this, please. This is what I'm trying to draw. This is like Wuse, Garki, Maitama, then down to Jabi Lake, right? Or down to treatment plant. So this is what the model. So this is, if you have, let me also say that before you do this model, you must have done the design fully. Must have done the design fully, right? So your own nice model is so that if tomorrow you made a mistake in the area of Garki or so, instead of 5 hectares, you use 7 hectares. You don't have to start afresh again. All you need to do is to come to this model, double click on it, and then change the size. And the model will reprogram itself. So I'll go back to climatology. I'll draw this. So ideally, if it's a physical meeting, we'll be following this gradually. Like here says, our first task is to create a new EPA project and make sure that certain default options are selected. Using these defaults to amplify the task given. It's a launch EPA swim if it's not already running, and select file new to create a new project. So we've done all that. It says select home, project preference, ID description to describe it. Okay, what is it talking here? Go to project, you go to default, which is what we do in every software. What do I want my rain gauge to answer? I want it to answer Aruji, rain gauge. Subcatchment, what do I want it to answer? Let's say S. Junction, J. Everything we did in outfall, I will say out. Go to subcatchment. These are default values. You can change them, you can leave them at default. Area of failure is 25. Our own is about 37, 0.37. The slope of the area, let's leave it at 0.5. Okay, so here you can go and choose the differential model. I won't teach you everything. I just want to introduce you to the whole thing. When you read the manual and you master it, don't worry, it's not difficult. I go to the subcatchment, conduit geometry, circular. I click on this circular. You take me to here. I'll see a lot of them. I can't hear you, sir. What is conduit length? I can choose anything, default value.
Hello?
The idea of default value is that.
Can you hear me?
Yeah, can you hear you, sir? Yes. We can hear you, sir. Can you hear me? Yes.
Okay. I'm a staff of a Federal Road Safety Corps. I'm joining the meeting.
What's the name?
My name is Okeke Fine Chuku.
Okay.
Okay, fine. I'm an engineer by profession. I'm working with the Federal Road Safety Corps, Safety and Engineering.
Is this your first day?
Pardon?
Is this your first day?
No, this is my first day.
Okay. Okay.
So I have been participating for the other that where I'm staying will have network issues.
Okay, you are 3 in number. There are 3 of you in number.
Hello?
There are about 3 of you in number.
Yes, from FRSC. Yes, actually 3 from FRSC.
Who are the other 2? Jonas and who again?
The other one is Okafor Modestus.
Okay.
Yes.
Okay.
Then we have IE Abo, Jesse, Jonas Abo.
Okay. And there's
Then,
one other person. You have 4 in number.
our Bata. Yes. Then our Bata, we have that is the man in charge of core safety engineering, RT Conven.
Okay, no problem. It's okay. Let's continue. It's okay.
Okay, please. I don't know if I can have the materials for this lecture.
Chat me up after the class. No problem. Just chat me up. Why we WhatsApp group? Chat me up.
Okay. Okay, please send me a mail to my email so that I can get I'll get your email, or possibly add your phone number so that I can be able to communicate freely with you.
It's okay. It's okay. It's okay. No problem.
So do you have my email address?
Engineer, I think after the class, look for my number on the advert or your boss. Chat me up. You get the materials so that we can continue with the class.
Please, I want to get something, please.
Okay.
Please text me a number so that I will just call you. No,
sir, I won't be able to do that now. Let's finish this class, sir. I will have time for that now.
Okay, I'm following the class. Yes.
Oh, thank you. So here,
no problem.
If you cannot
do it.
So here you choose the flow unit.
Network.
Network is bad. I can barely hear you.
Okay. I'm moving the phone. Okay, no problem. Let's see after.
Okay, so you can come here. You choose the flow, the units, liter per seconds, and what have you. Here you choose the routing method, kinematic wave or kinetic wave or steady flow. All these things, when you read the manual, you understand. If I say, there's no way someone can teach you a software in 2 hours. The person is lying to you. But the good thing about it is that somebody to give you a head up. Somebody to teach you the steps, how to see the software, the interface of the software. Then when you have a challenge, or when you're on your own, you can now practice and revise. But one good thing I'll do for us, because we'll be closing this class in the next maybe 20 minutes, rather than staying long, I'm going to copy us a video that will teach you everything on day 6, right? So I'll teach you the video. If you can sit down and watch the video for 2 hours, you will understand everything I'm talking about here. I'm going to share that video after the class. So this is default. Every software that we use always have a default. Like here, I use circular. I can change it and use rectangular channel. The height is 1 meter. If I'm drawing in meters, that means this will be 1 meter. If I'm drawing in feet, that means this is 1 feet. And so on and so forth. Here, side wall removed, no? Side wall, I'll say none. That means the 2 side walls are still there. It has side walls. So here you choose the member, trapezoidal member, you choose it. When you choose the trapezoidal member, the whole parameter changes. It will ask you for the left slope, the right slope, the bottom width, the maximum height, and so on and so forth. You're okay, you choose yes. What is the invert level of the manhole? You put it. Maximum depth, you put it. These default are not automatic. Roughness, you put it. They are not automatic. You can come back and change them, but these are just like defaults. Then some catchment defaults. Slope, 0.5. And change it to whatever value you want. Area, you put it 5 hectares. User ID label, choose what the label ID labels will be. When you finish, you press OK. Now, when you go to view, dimension, you can choose dimension. Let's say I choose meters. Well, all my drawing will be in meters. Then here, you come here, you choose your flow unit. You can choose any flow unit you want at the bottom here. Then if auto length is off, I've thought of that one. If it's on, I've thought of the implication. So this is where you set everything that needs to be set, right? This is where you set everything that needs to be set. When you set everything, then the first thing you draw is you draw your subcatchment. After drawing the subcatchment, if you go through the manual will tell you the next thing to do. But being I'm the tutor, lead person, I might not be going through all these manual step by step because I've read them. So this is the ID descriptions. Put them this way. Then the slope parameters, you put them. So yeah, we've done all this. So when we finish this class, you go through this manual. I'll upload it on the drive. I'll send to us. I'll send on the platform, and so on and so forth. When you go to the drive, I'll send you a corresponding video that you're going to watch. When you watch that video, you'll understand everything. So let me quickly continue here while I send us the video later on. So I'll come here. I'll put the nodes. Where are the water going to empty themselves? That's what I'm trying to put here. And the last point, which is the river, will be the outlet. These things look small. So I'll come here, map, node, I'll increase it to say 10. Link to say 2. So next I'll do, I'll come and link them up. Yeah. However, I'll click this select tool. If you finish, you must click the select tool. Always remember to click the select tool so that you deselect. So now I need to link the catchment to the drain. So what I'll do, I'll double click on this catchment. I'll double click on it, but the names are not showing. So I'll go to my map option, map view, and ask him to display the names of both the subcatchment, the ID, and what have you. Display those names. So this one is catchment 1. I'll double click on catchment 1. Outlet, I'll come to outlet, I'll click on it, I'll put J1. Once I press enter, you see a dotted line going from here to here. He's telling this thing that all the rain that falls here was going to this one first. So I'll do the same with this one. No, I just double click, sorry. I'll click property. Hard for will be J2. One parameter is missing in all of them, and that is the rain gauge. So remember, I'll come and create a rain gauge, and that will be all. So this one will be J3. So I'm telling him, empty the water into J3. And that is all. The next thing is rain gauge. Which is here. Click on the rain gauge, you drop it here. You now go and double click on it. You double click on it, you will find out that there's no file. There's nothing here. So I'll come here, I'll click on add. Or I'll simply come to rain series. When you open here, I'll click add. So what I'm going to do here now is to add a time series. I don't know if I've seen a time series before, but it tells you at what point the amount of rainfall. For instance, I can name this one Abuja time series. I'll come here, I'll say description of Abuja rainfall data. So this is like a rainfall data. Just so when I'll come here, I'll say, let's say it's a 30 minutes rain. It's a 30 minutes rain. Then I'll say, what are this thing? It says 0. But to make life easy for us, you can just go to the manual and copy it. So this is what the time series look like. This is what the time series looks like. What the time series is saying that in the first 1 hour, when there's no rain, first 0 hour, the rainfall is 0. After 1 hour, the rainfall is 0.5. After 2 hours, the rainfall is 1. After 3 hours, the rainfall is 0.75. The rain has peaked. After 4 hours, the rain is 0.5. After 5 hours, the rain is 0.25. After 6 hours, the rain is 0. That means the rain has stopped. This 1, 2, 3, 4, 5, 6 can be hourly. It can also be minutes. It can be minutes also. It means it's a 6-minute rain. If I assume it to be a 6 minutes rain, so this is how it is falling. All of us know that rain plateaus. When rain starts, it starts small. It starts from 0. It goes to 0.5. Then it peaks at 1. After 1, it starts going down again. So that is that. So that is how to build a rain gauge system. So the next I'll build a rain gauge. So depending on what you want, you can put 0 here. Which is 5 minutes. The rain value is let's say the rain value is 0. No, sorry, this is at 0. The rain value is 0. And at 0, 5 minutes. The rain value is say 20 mm. Or let's say 50 mm. At 10 minutes. So normally what you do is, this is that what we got in that IDF. Those values that we got on IDF. But before IDF, this is how you get it. Remember, you can go and ask for rainfall data from River Basin or from Ministry of Works or Ministry of Water. It will give you the rainfall data in that area. But Current and the Ministry of Works came together in 2013 and came up with some values for some states. That's what we're using. So all you need to do is the one you have, you bring it back into in form of a table. Right? You can go to YouTube and Google how to build a time series. It will come up with something like this for you. So with something like this, you now build a time series. So let's say after then it becomes 100 millimeter. Then after 15 minutes, it comes to, let's say, 150, and that's the maximum. And after 20 minutes, it comes back to, let's say, 120. And after 20 minutes, 5 minutes, it comes to, say, 50. And after 30 minutes, which is the end of the rain, it comes to 0. To see an idea of what you've done, click on View to give you a chart. So if you can remember your hydraulics in school, all those things we did, this is a typical time series of a rain. Even though this is not perfect, but it's something like this. When it rains, the rain will come to a certain level, it will plateau. And the plateau starts coming down. I'll close it. Remember the name, Abuja, very important. So I'll click OK. Then when I double click this rain gauge, all I need to do now is under series name, I'll click on it. Abuja will appear. I'll click on Abuja. That's all. You have done it. You have inputted it. Our rain format, is it intensity? I'll say yes. Rain units, is it in inches, in millimeters? Enter. Okay. So I'll close it. So when I come to this catchment now, I'll say catchment, you have to use, oh, it doesn't come here. Wait. Oh, yeah, RG1. Use this rain gauge. Enter. It's possible that you could use a different rain gauge, but let's use the same rain gauge. You can't believe me. The next thing you do is to put elevation so that the water can flow. So let's assume that this place has invert level of say 90. And here we'll have like say 85. Let's say here is upper downstream. So here will be less than 92. And this one will be say let's say 9. So I've imputed the invert level, which is the surveyor's point. This is something we already know as infrastructure expert. So I've designed the rain gauge, I've designed the catchment. Look at it, all the values are filled. The node, I've designed it. The pipe, it will choose the default. I can change it here. This circular pipe we're using, I can change it anything I want, but let me leave it as circular pipe. After that, I'll click on. Okay. Okay. There's an error in the settings I do. Record interval greater than time series. If that be the case, it means you have to go and check the recording interval. So I'll go to default again. So my run gave me an error showing me that the record interval is greater than the time series. So what I'll do is I'll try changing my time series to, okay, rain format intensity. So I'll put remove intensity. Here is intensity. So I think it's from default. I need to change something from default. So let me change it here. Under options. Under options. Good. Time steps. 15 minutes. This is where the error is coming from. This place is saying 15 minutes. Whereas me, I'm recording I'm recording 5 minutes. So I'll come here, I'll change it to 5:05. Adjust it. Okay. Recording interval. Okay, recording interval. Reporting. The problem is somewhere here. There's a problem somewhere. The time series that we need to sort out. Recording interval. Time interval is 1 minute. So I'll change it to 5 seconds. I think it's here. Here. Okay. So I think there's a small error somewhere about, yeah. So this is what, you see, because it fails, this result is giving me. It has no acceptable, so this is the value to give me, and that's the value I'm looking for. But so far, there's a slight error that I know if I take my time, I will get it, but I don't think there's need for me to take so much of your time.